Hi, this is part one of the video about mastering basic facts. What are the basic facts? That's when we're doing any of the four operations, adding, subtracting, multiplying, or dividing with single-digit numbers. So in this first part of the video, we're going to take a look at an important understanding that we need in order to think about how we might help students master basic facts. And in the second part, we'll talk about some strategies and some do's and don'ts. So the main understanding we need to develop for each of the operations is that there's a certain learning trajectory that students tend to follow as they learn the basic facts. So for example, here with addition, students tend to start by doing some direct modeling and counting, and then move towards some reasoning to help them remember these basic facts. And then finally, in the end, they learn to retrieve these without going through modeling or reasoning. So let's take a little bit closer look with addition what kind of trajectory this is. Most students begin figuring out basic facts by actually directly modeling those facts with some objects, some counters or their fingers, things like that. And so for example, if they're trying to figure out what's 2 plus 5, they might put out 2 objects and put out 5 objects, push them all together and count all those objects and get 7. More sophisticated is for them to count on from the first, so they realize they don't have to count the first 2 again in order to get the 7. They can just say start at 2 and then say 3, 4, 5, 6, 7. So that would be a more sophisticated process, and so they're up the learning trajectory a little bit from counting all. Counting on from the larger is even more sophisticated. Here they think about 2 and 5 and they decide, well, if I start from 5, count on from the larger, I only have to go 5, 6, 7, and it's a lot easier than starting at 2 and counting all the way up. So there's this trajectory at the lowest, and they're counting all of them. As they get more sophisticated, they learn to count on from the larger. Also in this counting trajectory, they learn to count abstractly without actually having those objects or those fingers in front of them, and they follow the same kind of pattern through these. Now, the fact that they're listed in this order suggests that maybe they do them exactly in this order, but there tends to be back and forth between these and some overlap. But in general, counting all and direct modeling tends to be initial, and towards the end they can count abstractly in their minds on from the larger, and that's more sophisticated. As they move beyond these things, and intermingled as they're learning with these things, they start doing some reasoning. For example, adding 0 to a number keeps it the same number, so they don't need to do any counting. When it's 5 plus 0, they know it's just 5. Or adding 1 gives them just the next whole number. So these are some important properties they begin to draw on and not have to worry about counting. They just come to know these. Same with commutative property. A plus B is B plus A, so 5 plus 2 is the same as 2 plus 5. I know they're both 7. I don't have to count one if I already know the other. Some known fact derivations means maybe they perhaps know some doubles, like 5 plus 5 is 10. So if they're trying to figure out 5 plus 6, they say, oh, well, 6 is just one more than 5, so it's 5 plus 1. It's 10 plus 1. It must be 11. Or maybe they go down. 7 plus 6 is the same as 7 plus 7 minus 1. Even more complicated is when they start redistributing. For example, if they want to figure out 7 plus 5, they can think of this 5 as actually being 3 plus 2. And so 7 plus 3 plus 2, well, I know 7 plus 3 is 10, so it's really 10 plus 2 or 12. Now that seems kind of complicated, but children learn to do this in their minds very quickly. And it seems like they have these memorized, but they're actually going this process of, I can split 5 into 3 and 2, add those 3 to the 7 and get 10, and now I know I have 12. Ultimately, the end of the trajectory is that kids don't have to think about any of these things. When you ask them 7 plus 5, they just know it's 12. But there's always a little bit of back and forth, and in different situations they might revert back to some of these lower down the trajectory. Ultimately, we want kids to end up at the high end of the trajectory where they're just retrieving these facts from long-term memory. The way we can get them to do that through some strategies we'll talk about in the next video.